Hey guys, and welcome back to part 3 of my Homecockpit series. It's been a while now since the last video. Reason for that is I had some other projects ongoing, my own simulator, some projects for another simulator that you maybe already saw on my Facebook page. And yeah, the biggest thing in the last few weeks was the A330 flight model that I created on my own. And today in this video I would like to show you how I created that model. So first of all, I would like to show you 5 nice little applications that I worked with. First of all, there's an application called AirWrench, and the aim of AirWrench is that you simply enter your basic parameters of your aircraft in all those tabs, and finally it creates an aircraft.cfg and the air file, and the final model in FS should almost be able to fly as you adjusted here. Problem was that basically it did not work as intended. So after I guess around 2 or 3 weeks working with AirWrench, I had to throw away the first approach and I started to work basically at the core at the air file. And for that I used 2 other applications. First of all, the aircraft air file manager, which is very nice to edit all those curves here, basically tables, and another one called AirAdd to work on these numbers, just these single plane numbers. Reason for that is that I'm using 2 different applications here. Aircraft Airfile Manager is nice to edit the curves or tables, but it's not nice to work on those numbers. So reason for that is if I open these same numbers in AirWrench in both editors, you see that there's a difference. So it seems to me that the 45 here is the plane value that is saved in the air file, and that this is an calculated value by formula. I saw some reports on the internet that if you enter values here, it does not work. And I think that's because it does not work converting this number back into this number. So I just adjusted numbers here in AirAdd. So 45 gets to 0.02197. So I have to use both applications, and both have advantages and disadvantages. Then we have a little application called AFSD, which shows what's going on in the flight simulator regarding numbers. So I have a few, I can open a few tabs here, and it shows things like the actual drag in pounds, lift, thrust, CL, CD, which are the lift and the drag coefficient, L over D, and all that amazing things that you need when you are working at the core. Another application here is the Advanced Jet Performance Calculator, which just needs the air file and the aircraft.cfg, and then you can, for instance, use the descent calculator, enter a descent you like to be calculated. Let's assume a gross weight of around 400,000 pounds, which corresponds to approximately 200 tons. Make that small 80 until IS 300. Section perform idle thrust, and then you get a descent time of around 23 minutes. Pretty cool to check your performance without flying the profile. So how did I start at the flight model? The most basic value or curve is the CL versus alpha curve, which simply represents the lift coefficient versus the angle of attack. And I simply adjusted that by the assumption that at a typical cruise, let's assume around 200 tons. The pitch is around 2.5 degrees. I saw that on a lot of pictures. So as the trajectory is 0 degrees and the pitch is 2 degrees without wind, we have an angle of attack of 2.5 degrees. And now you have to adjust it in a way, again with an assumption that we have small angles, that my lift is equal weight, and yeah, that goes by the basic lift formula, which is Q, which is the dynamic pressure, times S, which is the surface area of the wing, times CL. So yeah, and with that you get so your basic slope and the stall region over here. That's the most basic curve. Thereafter I tuned CD0. CD0 is the parasite drag, and you already saw the value. It's over here, and an add over here. So I adjusted that value. I simply turned off the engines and performed descent without engines, with the assumption that I can set up CD0 in a way that the induced drag is already known. The induced drag is CL square divided by the aspect ratio times the Oswald efficiency factor times pi. And yeah, aspect ratio is clear from your airplane geometry, and Oswald efficiency factor is simply an assumption. So I got my induced drag, and yeah, now I needed some numbers for the descent, and I found some tables here. I have to find the correct table now. It's from the quick reference handbook, which simply states it's the all-engine flame out, and you can see here that at 300 knots, decimal 82 Mach, with all engines stop, it takes about 50 minutes to descend from flight level 400 to the ground. The distance is about 100 nautical miles. So that is the basic thing, and together with the single engine operations, descent to landing, which is simply one engine out, one engine running, and together with the usual descent, you'll see that later. With the normal descent, you can interpolate and extrapolate your descent without engines, and so I could set up CD0 until the descent was fine. So again, an assumption, what to make it easier is I got rid of the Mach drag. So thereafter I had to adjust the ram drag, which is the ingoing impulse to the engine, and you can set up this value over here. Yeah. So and the nice thing of this value is that is independent of the engine parameter, just of the dynamic pressure, speed, and things like that. And so I could set up all those values here, and it's this airflow factor y over airflow factor over CN1. CN1 is a corrected N1 value. Nice also here, the formula is over here, how the thing is calculated. So you have an equal value over all that CN1 range. So that was the ram drag, and with the ram drag I could adjust the idle descent simply by adjusting the N1 value. So I have to calculate an idle thrust, and idle thrust is in the range around, first assumption, between 20% CN1 and 40% CN1. And now I had to adjust this value here, which affects the force of the engine, so the gross thrust, so that I have a netto thrust. So netto thrust is equal to gross thrust minus ram drag, which is the ingoing impulse, and I have also steady values here in the first assumption. And all that stuff I calculated with an Excel sheet. I made an Excel sheet where I entered all those values from the FCOM, international standard atmosphere values, and finally these values, which you can find here, came out, and it fits pretty well. So after the idle thrust descent, I could create the cruise thrust or the cruise N1 values over here, also with that Excel sheet, and for that I have another table. Where is it? Yeah, it's this table, N1 mode thrust control. The here below table gives the N1 to be set in cruise to maintain Mach 0.82. So I could adjust the N1 values with the weights, the flight levels to maintain Mach 0.80. And after that, I got all my basic values for the engines, for the lift, for the drag, and I could perform climb tests. So the current version of the model has, especially below flight level 100, too high climb performance. So I have to adjust that and further development steps. So now, as the basic flight model was already completed, I had to work on other things like spoiler drag, gear drag, flaps, brakes and reverser, fuel flow, and stuff like that. So first of all, I worked on the spoiler drag, which can be seen here. It's the emergency descent, of course with idle thrust and air brakes extended. And so with these numbers, the two weights, 150 and 200 tons, I could set up the spoiler drag. So thereafter I tuned the gear drag with that table. It's again a descent, idle thrust, all engines, landing gear down. Again with these two weights, and so I got the gear drag. The flaps were a bit more complicated, as at the point where I adjusted the values I had almost no data, so I looked on a few pictures on internet and I saw that the aircraft has around 3 degrees of pitch on a standard ILS approach, and with that I tuned the flaps values in a way that it worked. Basically just a raw estimation first. So finally I worked on the landing, on the brakes and the reverser, and I used these two tables here. So actual landing distance, configuration full, configuration free, and dry runway of course. And with these weights I could adjust the brakes in a way that I reach these landing distances. So as you can see here, for dry runway the reversers have almost no effect, just 2%, in this case 3% effect. So finally the flight model itself was completed, and now I worked on the fuel flow. So for the fuel flow I first adjusted a curve, and oops, again the wrong application. Let's take, yeah, that's this curve. It's simply chose the CN2, which is the corrected N2, versus the fuel flow constant. And first of all I lowered these values here to the right, which increased the spool up rate in higher CN2 and CN1 ranges, and so I got higher spool up values and almost perfect fuel flow randomly. So the fuel flow can be seen here. Cruise marked at small A2, flight levels, weights, and then you have the kilogram per hour per engine here. And they almost fit perfectly at the first try. That's pretty awesome. So last but not least, I adjusted the idle N1 and 2 values, which also come from the flight crew training manual. You can find these values, I guess, in the category idle parameters. And once again the wrong CN1. Yeah, with these two you can calculate your idle CN2 value, and then you can adjust everything, especially CN1 in this curve, which connects CN1 and CN2, and the idle thrust is around here. You have on the Pratt & Whitney 4168 A engines, you have around 23% and one idle. So that's it regarding first version of the flight model. Hope it was not too much information, especially in this Excel table. Pretty cool model. I think it's the best A330 model ever till now, and I hope that I will get the PIG controllers in a few weeks, and I can fly this model for the first time with GLFMGS. Till then, always 3 greens, and see you in the next episode. Bye bye.